Hello and welcome. My name is Philip Campos. I am a database consultant. I have been a Sybase DBA during 20 years and for more than 3 years now I specialize on MySQL. I intervened in many European countries, in Africa and in Switzerland for missions related to design and database audit, as well as missions related to fine-tuning and performance improvement on servers ranging from some gigabytes to several terabytes. If you want to install or use MySQL and avoid common mistakes, this presentation is for you. The smooth running of a MySQL server depends on setting the right parameter servers. If you want your application to run smoothly too, you must be very careful about how you are going to manage the data and choose the right storage engine. Architecture is the interaction between server parameters and storage engines. A good configuration guarantees the success of the application. An incorrect configuration will deliver poor performance under load and your system won't scale. If a system doesn't scale, the global performance of the application decreases when the load of the server increases. Do not change your hardware. Tune your MySQL server. In this presentation, I am going to present you a simplified description of the architecture of MySQL. I will put forward the main points of interest to install and tune your MySQL server. These points are the regulation of connection, the regulation of the SQL layer, and the choice of the suitable storage engines. It will allow you to take the good decisions. MySQL Server runs on Solaris, Linux, and Windows. The MySQL architecture is the same on all these systems. MySQL is a relational database management system composed of 3 layers, a 3-tier architecture. The first layer handles and manages connections to the server. The second layer analyzes, optimizes, and manages the queries submitted to the server. The third layer is made of multiple storage engines that read and write data. You choose one or several storage engines that suit your needs. Each server connection is a thread to which MySQL associates memory buffers. Read buffer size controls the buffer for sequential scans. Sort buffer size controls the buffer for sorts. TMP table size controls the maximum size of the temporary tables in memory that are used for group by operation. These buffers are dynamically allocated during the execution of queries. Which clients can connect to the MySQL server program? The MySQL Interactive client provides with the distribution. Any client using the ODBC or JDBC standard, PHP. Under Windows, the local clients can connect by using the following protocols: shared memory, NT-pipes, TCP/IP. Under Linux and Solaris, the local clients can connect using Unix sockets, TCP/IP. With all systems, the remote clients connect by using the TCP/IP protocol. The second layer is the SQL engine. This layer performs 3 functions: save into and fetches from the query cache if it is activated, query analysis, query optimization. The third and last layer, the storage engines. Among the most commonly used, MySAM, InnoDB, Memory. the high availability engine called the cluster NDB engine. There are also others such as merge, archive, federated engines. The availability of several storage engines is the feature that really differentiates MySQL or the other relational database management systems. You can choose in a single database to use MySAM engine for some tables, to use for others InnoDB, and for still others the memory storage engine, and so on. 2 points can help you decide which is the storage engine that fits your tables best. Do you need transactional capability? Which kind of locking is required? A change to the content of a table is called non-transactional when you never need to roll it back. The MySAM engine is perfect for this type of change. A change to the content of a table is called transactional when it can be undone. With databases, one says rolled back. For this type of change, the InnoDB storage engine is mandatory. In a transactional environment, it is possible to group related changes to several tables into a single united transaction. You can commit or roll back all the changes at once. For this type of change, the InnoDB storage engine is mandatory. MySQL can handle 2 types of locking. Table locking. A user updates a table. The table is locked as long as the change is uncommitted. Another user has to wait for previous change to be committed before he can, in turn, update the table. This is the way the MySAM storage engine works. Row level locking. A user updates one row while another user updates another row without having any of them that waits for the completion of the other operation. This is the way the InnoDB storage engine works. To summarize, the MySAM engine allows fast searches, does not support transactions, and locks tables. The InnoDB engine works in transactional mode and locks rows. A few important remarks about the various files used by MySQL. The my.cnf file, that is located under /etc on Linux, contains system parameters, size of the memory allocated, size of buffer, etc. The MySQL log files records events collected by the server itself, including errors when they occur. Finally, all the tables in the databases have a .iframe description, and for the MySAM storage engine in particular, the tables are written in 2 files, .myid and .my. You have now in hand the elements to make fundamental choices. You must choose your connection parameters, your query cache parameters, your storage engines. The parameters that still need to be set are those that control the size of the memory buffers associated to your engines. If you have a doubt, or if you wish to protect yourselves against any error, do not hesitate to get in touch with me by email at the address philip.campos@gmail.com. An investment in the tuning of your server assures you that your system will scale and will deliver good performance under load. Finally, I would like to thank Stéphane Farou for his attentive and effective help in the creation of this presentation. Thank you for your attention.